Hello there, welcome back. This is Lesson 7, Metallic Bonds, and this is our last content video in Unit 3A. So in the last video, we talked about the properties of ionic compounds, and just to give us a quick review, we learned that they have high melting points and high boiling points. Ionic bonds are very strong, and that's why you have these high melting boiling points, because it takes a lot of energy to kind of break those attractions apart. They form these crystalline structures, and those are for your solids, these very highly organized patterns, and that they conduct electricity in the liquid, so melted, or dissolved form only. So again, if it's melted or if it's dissolved in water, then it conducts electricity, not as if it was a solid. So those are for ionic compounds. And so today we're going to talk about metallic bonds, what they are, how they're formed, and the different properties of them. So metallic bonds, if you were to look this up in a textbook, the textbook would give you the force of attraction that holds metals together. It contains the attraction of free-floating valence electrons for positively charged metal ions. Now, that's a long definition. It's kind of hard to talk about. So what you need to know, that's what that stands for. What you need to know, it's the bond between metals because of the sea of mobile electrons. So whenever we talk about metallic bonds, sea of mobile electrons is the answer to almost all of the questions. So basically what that means is if we look at this picture, all of these, positive things represent the different metal cations, but these little electrons, they're just floating wherever they are. And that's why when we talk about the transition metals having multiple oxidation states, them getting a little bit weird, this is why, because the electrons, they don't just belong to one thing, they're just kind of flowing around. If you ever think about how water flows in the ocean or anything, they just kind of flow wherever they want. So that's the sea of mobile electrons. The electrons are able to move wherever they want, and that is what causes metallic bonds. Again, that is the most important part of metallic bonds. So moving forward, the sea of mobile electrons in metallic bonds, the valent electrons, they don't belong to any particular atom. They're just kind of floating around there. And so, for example, this electron may at one point belong to that ion, and then, it's going to move, and then later it will belong to this one, and then it will move again, and it will belong to that one. And it just kind of gets bounced around between these ions. So because of that, because of these sea of mobile electrons, you have very strong attractions between these bonds. So again, metals have these very high boiling and melting points. So again, these metallic bonds are very strong. And they're capable of conducting electricity always. So here is a huge important fact, always. Because of these free-floating, and we can call them delocalized, and all this means is that it has no specific home. So the electrons could be literally anywhere. So again, we talked about how the electricity is the flow of electrons. And if the electrons are always able to move in a metal because we sea of mobile electrons, metallic bonds are always capable of conducting that electricity. That is different from ionic bonds, because when an ionic bond is in a solid, all the negative ions are kind of packed in together next to the positive ions, and only when it's dissolved or liquid can they flow freely. But metals, because of these sea of mobile electrons, can conduct electricity as a solid, as a liquid, or melted metals. You normally don't see gas metals, but in theory that would conduct electricity as well. Okay, so moving on, we're going to talk a little bit more about properties. We'll talk about alloys. So alloys are a mixture of two or more elements, and at least one of those things in that mixture has to be a metal. And that metal takes up about 90% at least of the material. So basically what it is, it mixes with something and it increases the strength, the durability, something. It makes the main metal better. So you have one metal, add a few things to it. Now that metal is like a superhero. You can think of like, I don't know, um, Peter Parker. He's a pretty cool dude to begin with, but then inject, that spider bite. Now he's even better. That's kind of what these alloys are, these superheroes of metals. So, do you think of any examples of alloys? The pictures have some kind of hints. What do you think? So, here are some alloys that you've seen in your life: brass, bronze, stainless steel, sterling silver, steel in general. So, if you look at brass, if you play a brass instrument, it's made up of copper and zinc. Bronze, like the third place metal, is copper, tin, manganese, phosphorus, aluminum, silicon. It's a mixture of all these different elements. And because all these elements are coming together, they now make a much stronger, much better mixture of that element. It brings out all the good qualities of it. Okay, and here is another picture of different alloys. If you look up compound chemistry on Google, they have infographics on literally everything. So if it's a bit blurry, that is what you can look into. But this kind of shows you different alloys, different things that make it up, and it's pretty cool. Okay, so that's really it for metallic bonds. Again, it's super short. All you really need to know is that sea of mobile electrons. Again, which means you have strong bonds, so high melting boiling point, and because of the sea of mobile electrons, you can conduct electricity whenever. So let's jump into some review questions. Number 1 says a solid sample of copper is an excellent conductor of electric current. What type of chemical bonds are in this sample? So the key word here is a solid sample. And yes, it tells you copper. So if it's solid, that means you have to have metallic bonds. And again, that's that sea of mobile electrons. So the answer has to be metallic bonds. That is when electricity can be conducted as a solid only, because you have these free-flowing mobile electrons. Okay, review question number 2. What type of bond involved positive ions immersed in a sea of mobile electrons? So again, sea of mobile electrons, this phrase, it's not something I made up, it's something the Regents uses as well. The sea of mobile electrons is metallic bonds. That is, again, like one of the main parts of it, and the answer is literally like 90% of the questions. Okay, lastly, review question number 3, at STT, which substance has metallic bonding? So again, metallic bonding, we're talking about metals only, and so ammonium chloride is a compound of NH4Cl, so that's not that. Barium oxide is BaO. Again, it doesn't matter if you know these formulas. Iodine is a nonmetal. So this is metal nonmetal, and this has a whole bunch of nonmetals and a polyatomic ion. Iodine is just a nonmetal, so it can't be that. Silver is just a metal, and what holds those silver pieces together are these metallic bonds. And so that's pretty much it. Again, this is the last content video for this unit. The next unit, we'll talk about Unit 3B, covalent bonds, and we'll also talk about, molecular polarity and intermolecular forces. So that is it. Bye.